It's so weird because I can't hear the claps either, but it looks good. So I can see it. I've got like a wall of screen in front of me and my presentation's there and you're there. If you see me tweet about my home office before, I don't know how many pixels I've got in total that way. I think it's 5,000 something, but it means I do a lot of this, but I am paying attention. So I was just saying before we started, you guys couldn't hear it because it was in the headset, but so something there looks familiar because I have been to Aarhus before. And before I did this talk, when I was preparing for it, I thought I should try and find a photo of something I've done there. And the best photo I could find was like beer, but I could just see the name on the beer glass. And I realized I've actually done a lot of talks in Denmark before. I've also been to Billund as well. This is everything I remember from Billund. That was nice. I have been to Copenhagen many, many times before. That's usually the photo I take when I go to Copenhagen. I think most of you probably know where that is. It's an easy walk from War Pigs. That's my memory of there. So look, I thought we probably should talk some cyber stuff, and yeah, we can ask beer questions and things later on as well. And it was kind of cool when GoTo announced I was going to talk. It went out there in a tweet, which was great. Like, it's nice seeing these tweets and promotions for events. And I got tagged in this, and I shared the good news about GoTo. And someone gave me a reply on Twitter, and this is honestly like the first slide I put in this deck months ago because I knew this was going to be good and it was going to give me some good material to talk about something a little bit different to my last GoTo talk. And this guy said, just so I'm not mistaken, this GoTo is not the same GoTo that completely bungled the LastPass breach. Right. So I thought this was probably a good place to start. We can talk about password managers and bungling of breaches and things like this. So for those of you who are not aware, GoTo is also a company which owns things like LogMeIn, and it owns LastPass, the password manager. And LastPass, it did have some press, which some of you probably saw late last year. They have had press, let's say press, a number of times. And the press from LastPass on that most recent occasion was about the leaking of password vaults. And I thought that this is really fascinating because we are trying to drive everybody towards password managers, because we know that we can't have strong and unique passwords across everything because we've got like dozens, if not hundreds of accounts these days. So we need a password manager to remember the unique strings. We're not in a passwordless world yet. We still need the passwords. So apparently the hacker stole the customer's password vaults. And the statement in this story was that they took a copy of a backup of customer vault data by using cloud storage keys stolen from a LastPass employee. And it's fascinating, isn't it? Like all the dots that get joined together to ultimately put people at risk by exposing that the thing that is meant to secure all their other things. Now, there's a whole other discussion about how password managers should secure your data and how we shouldn't just have a single point of failure, such as a vault being exposed. But one of the things that happened around the same time is I was in one of our local post offices and I found this password manager. Like, they sell a password manager in the post office. And this is literally a photo that I took very recently, very close to me. And this is a good deal. It's like $4.90. Not every month either. You just pay it once off and you have this password manager. And the way this password manager works is it's got a little book, and inside you put in the name of the website, you put in the username, and then you put in the password and the date that you set the password. But it's even better than that because it has this facility for password rotation. Only twice. You can only set a new password twice. There's not got enough space for that. You need to go down another line then. But the funny thing about this, to be just a little bit more serious for a moment, is that we do joke about password books. But the reality of it is that 90% of people would be better off using one of these books and paying $5 once off and writing their passwords down and making them unique on every website than what they would doing what they're doing at the moment, which is remembering the same bad password and reusing it everywhere. And I think it's really important for us as technologists and security people to remember who we're building systems for. Like, we are building systems for people like my mum and dad, who my mum uses one of these books. But my dad, I just have using a digital password manager, not LastPass. So he's all right with that. But most people are probably going to be a lot better off just using a book. So let's not sort of joke too much about things that, some people say, oh, Troy, look at this stupid password manager. It's not even encrypted. It's like, yeah, but it's still much better than what most people do. Now, passwords remain one of our biggest challenges in this industry. And there's lots of good illustrations about the problems we have with passwords. And there's one that I really enjoy showing, which is related to Netflix. Now, what you do, and everyone can go and do this at home later on as well, it's quite entertaining. You go to Twitter and you do a search on Twitter. And what you search for is Netflix hacked. And you will find all of these tweets, and especially all of these images about people who've had their Netflix account hacked. Now, I'm air quoting hacked because when they say hacked, what they usually mean is someone logged into my Netflix account and changed something. Like Netflix doesn't have some security vulnerability that people take advantage of. The vulnerability is in the people because they don't have the password book or the digital password manager. They reuse the passwords and someone logs in and now they're in their account. And I found one recently that was just a beautiful demonstration of the problem. So this was the tweet. This person says, my account was hacked and a subscription for the $20 monthly Netflix was made. The hacker then changed my password and email, locking me out of my account, all while still retaining my payment info. And if you read the steps from the bottom up, right? So this is the emails that this person's received. Welcome back to Netflix. So someone's logged in. Your phone number has changed. So now they don't control the phone number. Your email address has changed. So now they don't control the email address. So this is a really, really good illustration of just complete compromise and account takeover that all began almost certainly with a weak reused password. So this person is trying to get in touch with Netflix, but Netflix comes back and says, to keep the account secure, I'm unable to make any changes at this time. I apologize for the inconvenience, which is kind of ironic, right? Because the account has been taken over. It is no longer secure. Someone else owns that account. But how does Netflix know? There's a whole other discussion we could have around identity assurance. Like, how do we actually know who is who? When someone says, this is my account, how do you know it's right? Like, do you check the email address and we can't do those things because someone else controls those now. So in our industry, we keep trying to come up with solutions for people usually being phished, socially engineered, or accounts taken over through weak credentials. So we come up with great mechanisms, great technical mechanisms. So things like multi-factor. So everyone would have seen these before, right? So multi-factor RSA Secure ID, it is a physical token. Every 30 seconds, the number rotates. After you put in your username and your password, you have to enter the value on the token. Now, this is true two-factor authentication because the first factor is the thing in your head. It's obviously the password and the username. And the second factor is something that you have to have. You have to have that token on your person. But one of the reasons that we struggle to get traction with 2FA, and what I mean by struggling to get traction, many big services like Dropbox have single-digit 2FA adoption rates. So less than 10% of people have it turned on. And one of the reasons is it's friction. These secure IDs are friction. It's something else you have to do. You have to remember to have the token with you. So people come up with solutions like this. And this is beautiful. This turns 2FA back into 1FA. All right, you still have the token, but you don't have to have the token with you. Because what you can do is you can get a webcam and you can point it at the token, and then you can be somewhere completely different. And you don't have to have it, you just have to know the URL of the webcam so that you can see the image. Now, there's actually a blog post about this. This is a real-world blog post. And the person's written up how the camera is seeing this token exactly as you see it here. And it's obviously very clear what the numbers are. But this particular person was so dedicated to try and circumvent 2FA and turn it back into 1FA, they even OCR'd the numbers. So they've got the code in there to read the numbers from the image, convert them back to text format. So then I guess they can like copy and paste them into that second factor challenge and circumvent the whole turfay thing. So we're always dealing with humans, and you know, I was going to say human stupidity, but I almost feel that that's a little bit too harsh, because I think we've got to be sympathetic to how hard it is for humans, particularly normal people, not like us, normal people who try and work around these security controls. Now, part of the challenge I think that people really have is it is very difficult to know what communication is legitimate versus illegitimate. If anyone's been reading my tweets in the last 24 hours, we've had someone trying to scam my wife because we're selling a fridge. And it's hilarious. And I'm going to post more stuff after this because I've got their bank account details there. I'm going to post that and just see what happens. But we're dealing with this stuff all the time. I'll give you an example. I got an email like this from my bank recently. Now, this is a legitimate bank. This is the actual email. It was sent to me. And I got this and I read it and it said, there's a new app. We would like you to download this thing and install it on your device. And I saw that and went, oh, no, we're not meant to tell people to download things via like random emails and install them. This looks fishy. I wonder what's going to happen if you tap on the button. But I don't want to tap on the button and actually download the thing and click the link, because if I do that, what if that just records that now I'm a sucker and they're just going to send me more spam? So I did this very advanced technique, which is on an iOS device, if you hold your finger on the button for long enough, you get a little prompt like this. It pops up. Doesn't click the link. It just pops up. And I zoomed in on it and it looked like this. Now, if you got an email from someone saying that they're your bank and the URL looked like this, would you trust it? Keeping in mind I can see you all. Shake your head, nod your head. No, like everyone's like, no, absolutely not. Now, I saw this and that was what I thought too. It's like, this doesn't look good. I wouldn't trust this, but I'm a professional. I'm going to give it a go anyway and just see how weird shit gets. So I clicked the link and it went here. c00.adobe.com. Would you trust this link? Nod your head, shake your head. No, everyone's like, no way. I wouldn't either. It was legitimate. And the reason I know it was legitimate is I got in touch with the bank and I said, look, I've got this. It looks really, really fishy. And not only did they say, yes, it's legitimate, but I ended up going in and doing a workshop for this bank. And as part of the workshop, I did a presentation at the end of the event and I showed them these slides. And it was really funny because I was looking at an audience like you guys there and I was showing this and there's just all the security folks from the front just doing this and they're swearing under their breath, something marketing department, like it's always the marketing department. And the point I'm making here is that it is extraordinarily difficult for normal people to avoid scams and online fraud when legitimate organizations are communicating in a way that looks like a scam. So it's like the double whammy. You get scammers trying to behave like normal organizations, and then you get normal organizations behaving like scammers, and no one knows what to do. So this is why we still have phishing. Now, one of the things we looked at earlier, we looked at Netflix and the account takeovers, and a lot of this is happening due to password reuse. And the thing is that the passwords that are being reused, for the most part, are known bad passwords. They're passwords which have been in data breaches before. We have this thing called credential stuffing, where people will take great big lists of passwords and email address pairs, and they'll come from a whole different set of breaches, and then they'll try them somewhere completely different. So one of the things I've been working on the last few years to try and combat this is a part of Have I Been Pwned called Pwned Passwords. And I want to show you how this works and try and encourage more people to use it because it's really simple and it's really cool and it's got great adoption at the moment. So this goes back to guidance from NIST back in 2017, where they said, you know how we have so many websites that say, in order to create a strong password, you need to have an uppercase character, a lowercase character, a number, and an alphanumeric character. Now, normally I've got a set of slides I show about this, but I did this last time at GOTO, so I don't want to repeat the same combination of content. But the funny thing is, every time you say to people, like, if you get challenged by a website to create a strong password and it's all just lowercase, what do you do? And everyone's like, well, you just capitalize the first letter and then you add a 1 and then you add an exclamation mark. Job done, we're good to go. So arbitrary password complexity is just absolutely terrible. NIST said what we should be doing is we should be looking for known previously breached passwords and disallowing them. So if we've seen a password in a data breach before, that's no longer a good password. Now, it's either no longer good because the person who used it somewhere before is now trying to use it somewhere again, and that puts them at risk, or somebody else used the same password because they've got a dog with the same name, or they went to the same school, or they like the same rock band, or something like that. There's some other really, really bad password criteria. Once it's been seen before, it's bad. So NIST said, stop this, stop using passwords from previous breach corpuses. And then they said, good luck. And that's it. Go out there and figure it out yourself. So I created a service in Have I Been Pwned called Pwn Passwords. And it started out with a low digit hundreds of millions of accounts. I think we had something like 200 million passwords in there. It's now approaching 1 billion passwords. And there's a page. It's on the passwords link on Have I Been Pwned. It looks like this. And the page used to say in big, bold text, you can check a password here, but don't enter your real password. And I thought, that's it. I've done the good deed here. I'm not asking people to enter real passwords. It's fine. And then it was on like CNN, and the reporter's like, hey, go to this website and enter your password. And it's probably for the best because I'm not doing anything bad with the passwords, and people will just learn that they're bad and then they'll change them. But there's something else cool that happens behind the scenes when you use this feature. There's an anonymity model. And I want to explain how this works. And I want to explain how you can integrate this into your own apps via an API. So here's the way it works. When you click that submit button, it makes a request to an API, which takes your password as entered. Now we can all see this is a good password because it has an uppercase, a lowercase, a non-alphanumeric, and a number. Good to go. So what we do is we take the password that's entered like this. Now let's imagine you're the app developer. So you've got the person's password. They're trying to register on your website. You get the password, and what you do then is you create a SHA-1 hash of it. Now, when you create a SHA-1 hash, you get 40 characters. You take the first 5 characters of their SHA-1 hash, so this is in your system. You take the first 5 characters, which means that there are now 35 characters left at the end of this. Now, if we do a little bit of mathematics, 35 characters of hexadecimal means that there are 16 to the power of 35 different possible values in those 35 remaining positions. If you want to know exactly what number that is, it's this. Okay, so there's loads and loads and loads and loads of different possible options. The important thing we're trying to demonstrate here is that if you only give someone the first 5 characters of a SHA-1 hash and you don't have the last 35 characters, the person that you give that prefix to has got no idea what the full hash is. So what you do is you give me that prefix and you call an API like this. So this is the way Pwn Passwords works with the API request. There's a model called K-anonymity. So you're giving the first 5 characters. Now you send that to the Have I Been Pwned API, and it comes back with a response with every single SHA-1 hash suffix that matches the prefix. So this is 35 characters long, and it's everything that is 35 characters long that starts with those first 5. Now, eventually, if the password has been seen before, you'll find a row like this one. And this row then has the suffix on it, and it has this number at the end of it, 83129. And what this says is that that full SHA-1 hash has been seen 83,129 times before. Now, that's really, really cool because you as the application developer have given me a piece of information that doesn't let me figure out the password, but I've given you a whole bunch of information. You've found the actual password within there. It's been seen 83,000 times before. I don't think you should let your customer use that password. Now, what makes this so beautiful is those 5 characters means that there are 16 to the power of 5 different possible API endpoints you can call. And that's not a big number. That's just over 1 million. So if I think about every single request that everyone in the world using Pwned passwords can make, there are only just over 1 million possible unique requests that can be made. That means we can do something really, really cool. Now, I'm going to show you what that looks like. But just before I go any further, all of this is open source. If anyone wants to get a hold of this, you can go to the I Been Pwned GitHub repository, pull down all the code for it. The reason why we got the FBI logo on there is because part of that code base in GitHub includes an ingestion pipeline where the FBI is feeding passwords into I Been Pwned on a regular basis. Why is the FBI doing this? Because they find lots of passwords. So they do a lot of botnet takedowns, they do a lot of malware takedowns, they have a lot of compromised machines, and they get those passwords and feed them into I Been Pwned so that everybody using the API can get protected against their customers then using those same bad passwords. Pretty cool. Everyone's happy. It's really nice, like running an open source project that the FBI feeds data into. It's so cool. Now, what's even cooler about it is it all runs behind Cloudflare as well. So remember just before I was saying that there are 16 to the power of 5 different possible API requests because we've got 5 hexadecimal characters. This runs behind Cloudflare. We see at the moment almost 5 billion requests a month to this endpoint. So imagine all the different services out there that can actually access a customer's password in plain text. So when can you do this? Hopefully you're not storing them in your database in plain text, but you can do this when they register because they enter the plain text into the registration field, when they log in and when they change their password. So a whole bunch of big websites out there getting the customer's plain text, sending it to I Been Pwned 4.93 billion times a month. And one of the really neat things about it is because it runs behind Cloudflare, we can do this. This is 1 day of traffic from recently, 167 million requests. But you'll see that 184 requests have been served by the origin. So if you're not familiar with Cloudflare, it's a reverse proxy. So they have edge nodes all around the world, hundreds and hundreds of them. They've got at least one in Denmark. I think they've got more than one just in Copenhagen. They've got one in another part of the country. So they can cache a huge amount of data at these edge nodes. What we're seeing is that we've got 6 nines. Everyone gets excited about 5 nines. We've got 6 nines of cache hit ratio. So if you're using this service for your customer, 99.9999% of requests are going to come probably from somewhere in Denmark, which is really, really cool. And this is what's helping it scale up to just enormous numbers. In fact, the bigger it gets, the more efficient it is because more stuff sits in the cache. So we're about to hit 5 billion. We're going to have some sort of party. I don't know. I'll probably have a beer. So Pwned Pass is going super cool. Now, a lot of these passwords are obviously coming from data breaches, and it's very interesting to see the way data breaches spread and also the way our data in breaches is used. There are very good ways of using the data. I think Pwned passwords is a very good way of using the data. It helps people. It makes the world better. Then there are bad ways of using the data as well, which brings me to these guys. Now, I don't know if anyone ever saw this website, WeLeak.info. The way it works is there's a big search box on the front page where you enter an email address. Sounds familiar, doesn't it? So you enter an email address in there and you say search, except unlike I Been Pwned, which just comes back and says, yes, you're in the Adobe data breach and Dropbox and LinkedIn. This one comes back and says, you're in Adobe and Dropbox and LinkedIn. Would you like all the data from there? And I don't just mean like, are you in there or not? It's like, would you like the usernames, the passwords? If it's Ashley Madison, would you like the really, really super sensitive personal stuff in there? And if you do, you pay a low, low price and you can get the data. So what WeLeak.info was doing, it was actually trading on personal identity data purely for financial gain, for no betterment of anyone other than the people running the service. This is what the website looks like now, which makes me very happy to see this. This is the FBI and friends. You're going to see a theme here. It's it is fascinating spending more and more time with these law enforcement agencies, how well everyone works together. We've got the NCA there from the UK, plus we've got the Dutch police and the FBI, we've got the Germans there. There's a whole League of Nations working together to try and keep us safer. So it didn't work out real well for WeLeakInfo. There was another one just before that as well. This was a service called Leakedsource. And Leakedsource started up in 2015. Same sort of thing again. Search term, you enter someone's email address in there, comes back with results, and then you buy their data. Multiple people bought my data and sent it to me. And the people that did that, I think, were trying to do something nice because they were basically saying, hey, look, you should be aware these guys are selling your data, and they'd send it to me and it would have a whole bunch of my personal information from data breaches, including things like really bad plain text passwords from more than a decade ago. But, this is what happens in data breaches. The data's always there. And what was really interesting with all of these services is that unlike Have I Been Pwned, where it's like you go to About and there's a big photo of me and links and here's what it is and here's how it works, the people running these services always tried really, really hard to be anonymous. You could not find information about them anywhere on the website, any of their promotional stuff. They'd hide their identity. And incidentally, they were promoting a lot on things like hacking forums. And what they'd do, they'd promote on hacking forums, and then in their terms and conditions, somewhere on the website would say, we're not doing anything illegal so long as you don't use this for bad purposes. You can only use it for good purposes. And then they'd advertise it on a hacking forum. So, read between the lines. They were trying very hard to fly under the radar, to be discreet, to be anonymous. But eventually in 2017, it got shut down and they found who was responsible for it. It was this guy. It was a guy called Jordan Bloom. He's a Canadian. He's 25 years old here. And on the one hand, he was running this service. He got charged with trading in stolen identity data. So running this service, which was like identity theft as a service, but also at the same time trying to be discreet. But whilst he was trying to be discreet, he took the money that he made selling all of our data and bought a bright green Lamborghini. Now, I would argue that if you want to be discreet, this is not the car for you. Right? Get, I don't know, like a Prius or a Camry or something like that. I like the car, don't get me wrong, but I just don't think it's a good way of being discreet. So stolen identity data is a big thing, and it is becoming bigger and bigger as the years go by. And we had a very, very big incident in Australia last year. In fact, we had two big incidents. I'm going to talk about one of them. One of these incidents led to the crowds of people we see here. And this is related to a data breach that we had in September of a telco. And I'm going to talk a bit about this particular telco in a moment. But the queue that you see here is people lining up at one of our motoring departments to change their driver's licenses, because the organisation in question, when they got breached, had driver's licenses disclosed. Now, this creates a whole bunch of really, really interesting issues around how we do things like identity assurance. And I want to talk about this a little bit more. It sort of goes back to the Netflix thing before. It's like, how do I know you are who you say you are? Because I just contacted the email address and the phone number on your account and they're the wrong. Oh, yeah, because the hacker took those. So I'll talk about Optus and the data breach and what ended up happening. So Optus is our second largest telco here. They're a very, very large telco. They had 11 million customers impacted in the data breach. Now, what was quite fascinating about this is it created a lot of conversation here in Australia, which is the same as the conversation we're having all over the world, about things like how we do identity insurance, how we retain data. One of the things we discovered from this is that they still had data of people who hadn't been customers for like 20 years, but they kept it. One of the discussions that came up a lot was data minimization. Now, this is something that I think that those of us either in Europe or like me who spend a lot of time in Europe are very, very conscious of, is how do we minimize the footprint of our data, because that reduces our risk. So very often you'll hear people say, look, it's very important when you use a service, do not provide any data that you don't have to. But think about driver's licenses. What would happen if you walked into one of these stores and said, I would like a SIM card, and they say, okay, you just need to give me a driver's license, and then you say no? Well, you don't get a SIM card. Like it's as easy as that. It's part of their process because they want to be able to identify you. There are some mandatory metadata retention laws in Australia that make it even worse because they want to be able to trace phone numbers back to individuals, but you can't withhold that information. One of the other big data breaches we had last year was ransomware of our largest private health insurance company, a company called Medibank. And a lot of people had very, very sensitive medical information about them leaked. And we had the same discussion. You can't go to Medibank and say, I would like a private health insurance policy, but I do not want to give you any information about my pre-existing conditions. All right, you don't get a policy. It's that simple. So that there are so many cases where we just can't reduce the amount of data that we as individuals hand over. So back to Optus and the driver's license numbers. You know, this is a fascinating thing. If we think about a driver's license, this is what they look like in our state here in Australia. Because Australia, every state has a different kind with a different set of numbers and a different pattern. They look like this in our state of Queensland. And what everyone was sort of losing their mind about was this. It's like 9 numbers on a card. Now, part of the reason they're losing their mind is that this driver's license number is a very significant part of how we do identity verification as a country. It's not just if you go and get a phone plan, it's if you go and get a bank account or a loan or any sort of credit. Driver's licenses and driver's license numbers are a large part of identity assurance. Why? It's ridiculous. It's a little bit like social security numbers in America. Like everyone has heard about this, the fact that social security numbers are like this secret which you give to everyone. And then when they get exposed, everyone loses their mind because they're part of identity insurance. So as much as we should be talking about not retaining this data and collecting things like this in the first place, we also need to have the discussion about is this really the way we want to verify people's identities, using some numbers on a plastic card? As it is in many parts of the world, if you look a lot younger than me and you go into a bar, they might ask for a copy of this. They might say, can you hand it over? And then the bartender will put it down there somewhere beneath the bar, and it has this number on it. It also has your date of birth, and on the back side of it, it's also got your physical address. So imagine, particularly, say, young women walking into a bar, handing this over to some stranger, and then they use this as some sort of identity assurance. It's nuts. I don't know what it's like in Denmark, but in our state here, September, apparently we get digital driver's licenses. So then you can just show them your phone and it will have a verification with your photo that you are over the age of 18 and you don't have to hand over all the other personal info. So let's talk about the data breach for Optus. This is the person who was responsible for it. The data got published to a public hacking forum. A lot of the news talked about it being on the dark web. It wasn't on the dark web. It was much worse than that. It was on the clear web. I like joking about that because very often you see in the press stuff about the dark web because it sounds scary, right? No one's scared of like the clear web internet forums. People are scared about the dark web. So the headline is always the dark web. But this was a public internet forum, got taken down by the same law enforcement agencies we saw on that slide with WeLeakInfo before. And this person, Optus Data, is the account that was set up to share the information. And they said, it was a regular API that customers use to gather their own data, but this URL has access control bug. And what later emerged is that this vulnerability that led to the data of 11 million customers in our second largest telco, a multi-billion-dollar company, the bug was insecure direct object reference. Now, if you're not familiar with that term, imagine you've got a URL and it's got a number in it. And you look at it and go, oh, I wonder what would happen if I change that number. And you get someone else's data back. That is the level of sophistication that was involved here. IDORs, classic bug. So this person found this vulnerability, and it then brings into frame another discussion here about if you do find a vulnerability, what do you do? Who do you talk to? One of the problems that we constantly have in this industry is around disclosure. So how do we report vulnerabilities to an organization? Because so many times when people do try to report a vulnerability, the organization is very defensive. Now, I've had so many occasions where I have literally loaded data into Have I Been Pwned. I've had millions of records with credit card details and personal information, and the organization is literally going, no breach, no breach. I'm looking at it going, looks like a breach, smells like a breach. And they deny it and they reject it. And it is constantly hard to get organizations to take it seriously. Now, the reason I mention it here next to Optus is that the person who posted this data to this forum also posted this. So this was the old Breach Forum website. Now, Breach Forum got shut down earlier this year. That superseded one before it called Raid Forum. That got shut down last year. These clear web websites don't tend to last a long time if you're trading in stolen identity data. And this person, Optus Data, said, Optus, if you're reading, we would have reported exploit if you had method to contact. No security email, no bug bounties, no way to message. Incidentally, all of this bad grammar and bad spelling, this is the original messages. So I like to just include everything the way it was. Now, whether or not they could find a contact at Optus wasn't a good reason for them to dump data publicly. It definitely wasn't a good reason for them to try and ransom Optus for $1 million. So that's what they asked for. They said, could we please have $1 million? And Optus said, no, you can't. And tangential story, this post sort of disappeared shortly after that, and this person posted an apology on the same hacking forum. And I think the conclusion that many of us have reached is that whoever was responsible for this, their parents got a knock on the door from the Australian Federal Police and they got sent to their room to think about what they've done, because this was like the level of sophistication, right? It's often, if not legally children, like under 18, very young adults. So anyway, this person said, look, we could not find a security contact in order to report the vulnerability. This bit is very, very common. So all the time, I get people send me data breaches and I go, okay, it's legitimate. Now I need to go and find someone at the company because I need to disclose it rather than just load into Have I Been Pwned. Now, we have an industry standard way of publishing information related to people who might find security incidents. And it's a spec called security.txt. And if you haven't seen security.txt before, it's very much like a robots.txt. Now, I'm sure any of you out there developing websites have seen a robot.txt before. This is what the security version of it looks like. You put it in the .well-known directory of your website, and it is a text file. This is how sophisticated it is. It is a text file, and it has contact information. It can also have things like a public key. So Google has published their public key here because maybe the sort of people that find security vulnerabilities want to encrypt their communication before they send it to you. They've also got a policy here. They've got a hiring policy as well, because people that find things like a security.txt, maybe they want a job. So this is Google's. BBC's got one as well. They've got a very long one. You can see how small the scroll bar is on the right. Like it just goes on and on and on. This is the largest Australian website to have one. This is realestate.com.au. Self-explanatory name. It's property listing for sale, for rent. This website has one. That's a really good one as well. So check that out. And you see that we have contact information there, encryption information there, policy. Now, incidentally, if you're looking at this policy and you see the path in the URL and it says beg bounties, this is not a typo. So if you haven't heard of beg bounties before, it's when people go through, they find usually your security TXT or some other security address, and then they email you, and instead of it being a bug bounty where they've actually found something serious, they send an email and it'll sound serious. It'll be like, look, I was looking at your website. I'm a security researcher. I'm a white hat. I found something serious. Do you have a bug bounty? And you're like, no, I don't. Maybe I could send you a sticker if you found something. What is it? And they're like, your SPF record is misconfigured. Please, can I have money now? So this is a beg bounty when they're just finding things of very, very little consequence and asking for money. So the point is that we have a spec. We have a way of publishing information so that we can be contacted if someone finds a security vulnerability. Now, remember that the person in that breach forums post before said they couldn't find a contact for Optus. I went and had a look at Optus's security.txt file. Here's what it looks like. This is today. I said, this is still now. So even after that security incident, they still don't have a published way using the standard spec for people to get in touch with them. In fact, after the Optus data breach, I put out a tweet and I said, just curious, can anyone find security contact info for Optus? No results. So usually what ends up happening when people can't find a security contact and then they get in touch with me and I can't find a security contact is eventually I put out a tweet and it ends up being like this. Has anyone got a security contact at? Now you can go and search for it and you'll see this. And the thing is, like, every time someone sees one of these tweets, even though I don't say it, they know what it means, right? Like they know something bad has happened. You don't want to be in one of my tweets. You never want me contacting you. Trust me. But if you do have me contact you, you'd much rather have it at something like a private security address where I can encrypt my communications rather than it being a public tweet like this. So keep that in mind. Get a security.txt. It is the cheapest, easiest thing you can do to make yourself more discoverable to researchers. Now, changing pace for a bit, we spoke a bit about passwords, password reuse, credential stuffing lists, and we also spoke a bit about 2FA. And 2FA has been enormously good at circumventing the problem of credential stuffing. So remember, this is where there's big lists of email address, password pairs. They're breached from one place, and then hackers try them in other places, and because people get in. So 2FA is great because it stops that. So now you need the token as well. What's really interesting about this industry is every time we as defenders build something good like 2FA, someone comes along and finds a way around it. And I don't just mean the webcam. That was someone who should have been protected by 2FA finding a way around it. But the bad guys who are then trying to sell your data and steal your data and monetize you find ways about it. Which brings me to Genesis Market. Now, this is really interesting. This was in the news only a few weeks ago. And this is a service which originally started back in 2019. And the way Genesis Market worked is they said, look, there is a marketplace for credential stuffing lists, email addresses and passwords. But because of, not just 2FA, but because of things like, have you ever logged in somewhere just with the username and password, and then the website says, this looks a bit unusual. We've sent you an email. Could you please click the link? So now that they're verifying that you still control the email. Or you might have seen things like user behavioral analytics, UBA. So, hey, this person normally logs in from Australia. Now suddenly they're logging in from Beijing. Like, this is unusual. Maybe we should add an additional challenge. So what Genesis Market did, and then of course there's 2FA. Don't forget 2FA. So what happens when you log in and you need 2FA, the username and password alone are no good. So anyway, Genesis Market came along and said, well, what actually happens when someone authenticates to a website? So you go through the authentication process, username, password, maybe 2FA, any other challenges, any other UBA stuff, any other back channel emails, SMSs. Eventually you're logged on. What does it mean to be logged on? Well, normally you get a cookie. So you will get a cookie set on your browser. We might call it a session cookie or an auth cookie. It has some sort of a cryptographic token in it. And as you browse around the website, your browser will send that cookie back. So what if you could just steal the cookies? Because if you had the cookies, you've got post-auth material that can keep you authenticated. This is session hijacking if you have the cookies. But because websites are getting smarter and smarter, usually not only do you need the cookie now, but you need other material about the browser. So for example, this cookie works, but only for this user agent string. or the person's using this language setting, or other observable traits of the browser, so that the website can say, even if this person gets session hijacked, it won't work because we need the fingerprint of the browser and the cookie. So Genesis Market came along with malware that would infect users' machines, and it would capture the username, the password, but it would also capture the cookie and the fingerprint. And then they put it all up for sale. And this is what it used to look like. You could go through here and you could see a list of victims that you could then buy. So here's one zoomed in a little bit more. So this person was authenticated to Dropbox and the Apple Store and Gumtree. They're in the UK, and you can buy their data for $41.30. Now, that's a bargain because it's normally $59. This was a sale price. So you buy their data. So now you have the fingerprint material and you have the cookies as well. Now, you, as a technical person, could go into your browser and you could go and you could set that cookie into your own session. You could hijack the session, but you'd need to also set the fingerprint. It gets a little bit complicated. So they created a plugin, a special plugin that you'd run in your browser so that after you buy someone's identity data, your browser will start to emulate the fingerprint that they had on their browser, and it would take the cookies as well. And because they're a very service-orientated company, they told everyone that they care about your comfort. So as you're hijacking someone's session and ripping off their identity, your comfort is cared for, which I think is very important in a criminal enterprise. Now, this is how it worked out for Genesis Market. I love seeing these photos. As I mentioned, this was it was probably about 6 or 7 weeks ago. Genesis Market got taken down and a whole bunch of people got arrested. In fact, about 120 people in the initial round got arrested. This is someone in the UK being escorted out of their home by the NCA, the National Crime Agency there in the UK. This is what the Genesis Market website looked like once it got taken down. A little bit like the WeLeak info before, wasn't it? It's not just the FBI that's on here. We've got the AFP, they're our Australian Federal Police. We've got the Dutch, we've got the Canadians, we've got the Germans. It's like it's again, the Justice League of Nations of law enforcement agencies taking down cybercrime. Now, that was cool, but the bit that I thought was the coolest is that there's a bit in here where the FBI is telling people to go to Have I Been Pwned. Now, I was always worried when I started this service that one day I'd be contacted by the FBI. But this is in the good way, right? Where they're like, hey, we actually think you can do something useful here. And that what they said is, we'd like to give you the Genesis Market victims so that you can put them in Have I Been Pwned, and then people can come and see if they're in a data breach or not. Now, this is really neat. And the reason why the FBI doesn't just contact everyone themselves is, can you imagine if you were in that breach and you got an email and it says, hi, we're the FBI. We have your data. You had malware on your machine. Good luck. Would you believe that? That'd feel like an ANZ email, wouldn't it? It's like, I wouldn't trust that at all. Download this app. So they view Have I Been Pwned as an independent party. And they provided me the data. There's about 8 million records in there that went into Have I Been Pwned. And that was great because a lot of people discovered that they had malware on their machines. And we put a blog post out with a bunch of guidance, which usually boiled down to virus checkers probably also get rid of the machine and just go and reformat and go from scratch. So that bit was cool. But the thing that I found the coolest, and I guess maybe like my little sort of geeky way, is that if you have a look at this image, right? You know, we all know the hacker image with the hoodie and the green screens and everything. And I like the way they've got, the hacker on the screen looking back at you. Hackers always use binary as well. I don't know if you've noticed this. There's binary on the screen. But the FBI agent has got their own hoodie and they're looking in at the hackers, and you'll see at the top of the page, it says this is called Operation Cookie Monster. And of course, now you understand because there were cookies, which was part of the Genesis Market model. So the FBI agent's there on Operation Cookie Monster with the hoodie on, and on the desk next to the FBI agent, they're munching away on cookies. which I thought was wonderful imagery, and it's a really light-hearted, positive note to end like the formal part of the talk. Isn't it cool that the FBI has such a good sense of humor? I love that.